Let's take a look at this example dealing with negative exponents. We actually have a number of different negative exponents here, and we're asked to simplify this expression here. So we have 4 times the quantity, a times b to the negative 2, divided by 3a squared b to the negative 7, all raised to the negative 2 power. Now we've talked a little bit about how to handle negative exponents inside of a fraction. We know if it's in the numerator, we'll move the term to the denominator and make the exponent positive, and if it's in the denominator, we'll move it to the numerator and make the exponent positive. But we have not really talked about what happens when you have the entire fraction to a negative exponent. So before we hop into working this example out, let's just briefly talk about that. You could think of this 2 different ways, and they're both correct. You can basically start whichever route makes the most sense to you. If you have x over y all raised to a negative exponent and the whole thing's raised to a negative exponent, you can either use that exponent rule that you've learned previously, where you can distribute the exponent through to both the numerator and denominator, and you could have x to the negative m divided by y to the negative m. And then if you want to, then you can switch the places that where they are and write it as y to the positive m divided by x to the positive m. So that's one route, and that's totally fine, and that works, and that's correct. Another option, though, that you might want to consider is if you have a negative exponent. See, if you took this guy a step farther, you could actually pull the mth power back out and write the whole thing as a fraction again, but it would be y over x as opposed to x over y. So another route you could go is just leave it as the fraction that it is, only we're going to take the reciprocal of the inside and write it as y over x as opposed to x over y, and then the exponent will be positive m instead of negative m. And so that's all that happens is you take the reciprocal of the fraction on the inside of the parentheses, which is changing all the numerators to denominators and vice versa, and then you can take that exponent and just write it as a positive value. And then if you took it a step farther and distributed the exponent, now you would get y to the m over x to the m. So you notice these actually lead you to the same answer. It's just a matter of personal preference which way you get there makes the most sense. Okay, so let's come back to this example now, and let's try it again. So we can either mess around with the negative exponents on the inside of the parentheses and deal with the negative 2 exponent later, or we can go ahead and distribute it right now and then go ahead and take care of the negative exponents in just a second. So I'm kind of leaning that way. We certainly don't have to, but that's kind of the way I'm leaning. So let's go ahead and take this negative 2, and we'll go ahead and distribute this guy to every term inside the parentheses first. Now the 4 doesn't get raised to the negative 2 power, only the things on the inside of the parentheses. So we'd have 4 times the quantity, and actually we don't need parentheses anymore now, a to the negative 2, b to the positive 4, because you have a power to a power, so you multiply negative 2 times negative 2, you get positive 4, divided by 3 to the negative 2, a to the negative 4, that's a to the second to the negative 2, and then b to the positive 14. Okay, so that makes sense. So let's maybe bring this guy up here now. I'll go ahead and put that 4 just in the numerator of the fraction, just so we don't have a term and a fraction. Just go and put the 4 right here. Now we have to take care of these negative exponents. Everybody I'm circling in yellow is going to have to move. So the numerator terms are going to have to go to the denominator and vice versa. So we'd have a to the positive 2 in the denominator. We'd have 3 to the positive 2 now in the numerator. We'd have a to the positive 4 in the numerator. The b to the positive 4 that's already in the numerator will just stay there. And then b to the 14th power will stay where it is in the denominator. All right, so we're almost done. So lastly, we just have to clean up any remaining terms. Let's see, 3 squared is 9, and 9 times 4 is 36. So any numerical values, we can reduce that down to just a number. Then we have, here I'll circle this in pink, a to the 4th divided by a to the 2nd. Use that property where you subtract exponents. A to the 4 minus 2 would be a to the 2, which is positive. So that'll stay in the numerator. And then in yellow, we'd have b to the 4th divided by b to the 14th, which would be b to the 4 minus 14, which is b to the negative 10. But now where do we put that? Well, let's put that in the denominator and make it a positive 10. Because if we left it b to the negative 10, it would be in the numerator, of course. But let's move it to the denominator so we have a positive exponent there. So looks like our final answer is 36, a squared divided by b to the 10th.